All right, good morning. Welcome back to our biomathematics class, mathematical modeling, biomathematics. And in this question, we are asked to find something. They say that a model for competition between two species is given by this equation and this equation, that the dt is equal to into 1 minus h minus p. You close the bracket. Then the second equation said that the p dt is equal to p in bracket of 1 over 2 minus 1 over 4p minus 3 over 4h, you close the bracket, okay? And then I say that where h of t and p of t are representing the densities at time t. Now the first thing they say we should identify is the critical point, okay? The critical point. Now let me take you back to calculus, okay? When we did calculus, or if you can go to my video on calculus, if you remember how to find critical point of a differential of any equation at all. For example, you are given that y is equal to maybe 3x squared or maybe 3x cubed plus 6x squared minus 5s plus 2. And they say you should find the critical point. The first thing you do is to do what? You differentiate. The y, the s will give you, this time this will give you 9x squared plus 12x minus 5. Then you differentiate, you equate it to 0, and then find the value of your x here. So that is exactly how to find critical point. So in critical point, the first derivative must be equal to 0. Okay? So that is it. Then you now find what you are looking for. So that is that. So now, what do we do here? So at critical point, you tell them that at critical point, then that dh dt will be equal to 0 and dp dt will be equal to 0. So let us equate this to 0. So equating this one to 0, we have that h into 1 minus h minus p is equal to 0. And if you can remember in mathematics that when the product of two things is 0, automatically one of them is 0. So we can say that either h is equal to 0 or 1 minus h minus p is equal to 0. So we can conclude here that move everybody to the other side, that h plus p is equal to 1. If this one move to this side. So, comma. So the same thing here, that this one will be 0. So if here is 0, we'll have that what? That our p into 1 over 2 minus 1 over 4p minus 3 over 4h will be equal to 0. And when the product of two things is 0, automatically one of them is 0. So either p is equal to 0, or we have that 1 over 2 minus 1 over 4p minus, let me call this equation 1, and then 1 over 3 over 4ph will be equal to 0. So the LCM there is 4, so multiply everybody by 4 so that we can clear the denominator. So multiplying by 4 here, we're going to have a 4 times this to give us 2, minus 4 times this to give us p, minus 4 times this to give us 3h is equal to 4 times this is 0. So everybody moving to the other side, I'm going to have that p plus 3h is equal to 2, equation 2. So now to get the critical point, the first critical point you are going to get the critical points. That is for question number A. For the critical point, the first critical point we are going to get is when they say that h is 0 and p is 0. You know, the critical point you are getting is h comma 0, h comma p, sorry. H and p are the critical points. So you are writing the h before the p. So h and p. So we have when it is 0 comma 0. So the first critical point is 0 comma 0. Now the second critical point is when h is 0. When h is 0, if I put h to be 0 here, I'm getting that p is going to be 1. Look at it. If we put h to be 0 here, you will automatically see that p is equal to 1. So when another one is when h is if you are putting h0 here, you are coming here to substitute, please, not in the same equation. If h is 0 here, we substitute it here, please. So when h is 0, if you put 0 here, we're getting that p is 2. Okay, so we have that when h is 0, that p will now be 2. Sorry, p will be 2. So the next critical point, number 3, is now when p is 0, you now put it here. So if p is 0, we are noticing that h is 1. So when p is 0, h is 1. So, but you will not write it p comma h. It must be h comma p. So that means when h is 1, that p will be 0, or when p is 0, h is 1. So the final critical point you are going to get is by solving equation 1 and 2 simultaneously. So if you solve it simultaneously, let me solve it here. I'm going to have that h plus p is equal to 1 and 3h plus p is equal to 2. So if I subtract, I'm going to have that this and this will give you minus 2, right? Minus 2h is equal to this and this is going to give us minus 1. So our h here is half. So if h is half, if you put half here, if we put half here to get our p, we have that h plus p is equal to 1. So h, which is half, plus p is equal to 1. So therefore my p will now be 1 minus half, and 1 minus half is still half. So the final critical point is when h is half, p is equally half. So these are all the critical points. We have answered question number 1. So for question number 2, that is question number B, sorry. For question number B, A said identify all the critical points, and these are the critical points. So question number B said find the corresponding linear system of each of the critical points. Now, to get the linear system of each of these critical points, what we are going to do is simple. We are going to find the Jacobian of each of them. We're going to find the Jacobian of each of them. Then from here, we'll now know if they are stable or they are not stable, and then the rest of them. Okay. So that is what we are going to do in this case. So now, let's move. First of all, let us find the Jacobian of the whole system first, before we talk about the Jacobian of each of the critical points. So for the Jacobian of each system, permit me to clean here because my board is too small. Okay, to find the Jacobian, like I told you, there is a shortcut to it. The shortcut is, remember that this is the first line. Just take this first equation as the first line. So we're differentiating this first equation with respect to p, and then we put it in the first line. Then differentiate the second equation with respect to h and put it in the second line. Very, very simple. So always remember that that is the easiest way to do it, even if you don't want to write the formula. But if you want to write the formula, no problem. It's still the same thing. If you want to write the formula, no problem. It's still the same thing. So we are going to have the first equation we are differentiating. Is it with respect to p or with respect to h? I think it's with respect to h, not with respect to p. Yes, we are differentiating the first rule with respect to h. Is it? In the first rule. Okay, sorry. In the first rule, we are differentiating this with respect to h and with respect to p. Yes, in the first rule. Then in the second rule, we are differentiating this one with the same respect to h and respect to p again. So if you remember, the formula will now be partial h. We are differentiating, and what are we differentiating? Which we are differentiating the h, the t. Okay. So now the same thing again, partial, but with respect to p now. Partial p, and it's the same thing we are differentiating. Partial the h, the t. So we go to the second line, the same thing again. We are differentiating the with respect to h and with respect to p again. So we say partial h of this now, of the p, the t. Okay. You come to the other side again. Partial, sorry, 1 minute. Okay. So what are we going to have? So here we're going to have partial p, then we'll have the t, the h, the t. Okay. So j will now be equal to, so let's go again. Like I told you, we are differentiating this with respect to h. So differentiating, in fact, open the bracket to have that this is going to be h minus what? H squared minus ph. Okay. So to differentiate h with respect to h, I'm going to have 1. To differentiate this one with respect to h, I'm going to have 2h. To differentiate this with respect to h, I'm going to have minus p. That is for that side. So we go to this side again. We're differentiating this same equation with respect to p. And with respect to p, now this is where the only p is. This is 0. this is 0. So I'm going to have minus h here. So this side is minus h. Okay. We now come to the second equation. From the second equation, we are going to differentiate again with respect to this. So we are going to have, for the second equation, what are we supposed to have? Differentiate. Okay, open the bracket first. If you open the bracket, I'm going to have p over 2 minus p squared over 4 minus 3ph over 4. Okay, so to differentiate, sorry, sorry, to differentiate with respect to h for this side, I'm going to have this is 0, this is 0, minus 3p over 4, minus 3p over 4. So for the other side, I'm going to have what? Differentiate with respect to p. I'm going to have that half 1 over 2 times this. I'm going to have 2p over 4, which is p over 2, minus p over 2. This side is going to give me 3p over 4. So, sorry, 3h over 4 minus 3h over 4. Okay? So, that is the Jacobian. So, from this Jacobian, what we are now going to do is now to start to substitute the critical points. We start substituting the critical points. So that is that. So now let us start substituting the critical point, because we are asked to identify, we are asked to find the corresponding linear system for each critical point. So the first critical point, if you can remember, is 0, 0. So J, I hope you know that this thing is J of P and H and P. Yes, this is J, H, and P is equal to this. So H 0, 0 will now be anywhere we see H, we put 0, and anywhere we see P, we put 0. So this one is going to be, if I put 0 here and put 0 here, I'm having 0 here. Here is 0. Here is T0. Then here will give us half. Okay? Here will give us half. Is that correct? So check your own very well if it's correct. Okay, sorry, here is not 0. Here is 0, 0. So I'm having that here is 1, not 0. So here is 1. So that is for the first one. So we'll tell them that the linear system, because we're asked to find the linear system. The linear system is just simple to put that here is H, H and P. So you tell them, don't put it here. After getting this, you tell them that the linear system, the linear system will now be just 1, 0, 0, half. You now put H, P here. That's the linear system. Very simple for the first one. So we're going to check for the second one. So please permit me to always clean this one that I've written, so the second one, if you can remember the second critical point, we have that J, that is when it is 0 again. The other one was 2, if I can remember. 0 and 2. Yes, that's true now. When it is 0, it is 2. Yes, 0 and 2. So for 0 and 2, we go again. For 0 and 2, that means anywhere you see H, you put 0. And anywhere you see P, you put 2. So if I put 0 here and put 2 here, I'm going to have 1 minus 2. And 1 minus 2 gives us minus 1. Okay? So the next one I'm going to have is, here is automatically 0. So if I put 2 here, I'm going to have 2 taking care of this will be minus 3 over 2. Okay? Then finally, if I put 2 in the other side, what am I going to have? If I put 2 in the other side, if I put 0 in H here, this is gone. If I put 2 here, I'm going to have 2 divided by 2 is 1. So half minus 1 will give us minus half. Okay? So you tell them that the linear system will now be what? Minus 1, minus 3 over 2, 0, and minus 1 over 2, then H and P. So that is the linear system. Okay? So you say we should find the corresponding linear system. Permit me to clean here to do the next one. To do the next one, I'm going to have J of, we remember when it is 1, it was 0. So now, that is, if you see H, put 1. If you see P, put 0. If I put 1 here, if I put 0 here, this is gone. If I put 1 here, that is 1 minus 2. to give us minus 1. Okay? Yes, minus 1. So if I put 1 here again, it becomes minus 1 again. If I put 0 here, here becomes 0. If I put 0 here, here becomes 0. But if I put 1 here, I'm going to have half minus 3 over 4. That is 1 over 2 minus 3 over 4. The LCM here is 4. That is 2 minus 3, which is minus 1 over 4. Okay? Minus 1 over 4. So I'm having minus 1 over 4 here. So the linear system, you now write them that the linear system is just to attach H and P. That is the linear system. Okay? So my board is too small, so let's just be managing it. So the next one is J. The next one is J of P. That is the last one, number 4. That is when it is half, it is half. So now to do that, if I put half here, here becomes 1. And 1 minus 1 is 0. If I put half here, so here is remaining minus half. If I put half here, here is remaining minus half. If I put half here, that is minus 3 over 4 multiplied by half. I'm going to have minus 3 over 8. Minus 3 over 8. So if I put half here, half and half. So I'm going to have 1 over 2 minus half will give us 1 over 4 there. Half will give us 3 over 8 here. So the LCM here is what? Is 8. So I'm having 4 minus 2 minus 3. 4 minus 2 minus 3 will give you minus 1 over 8. Minus 1 over 8. So the linear system is just to put H and P here. So that is that for question number 2. So question number 3 said we should determine the stability of each of the critical points. We're going to determine the stability of each of the critical points. Okay? Now, don't forget that to determine the stability of each of the critical points, that we're going to be using, what is it called? We're going to be using, what's the name of this guy? Engine value. We're going to be using engine value. And then for engine value, it's very simple. Just for each of them. So let me clean here. We're now answering C now to determine the critical point of each of these. So when we have J of 0, 0, I think we had 1, 0, 0 and half. 1, 0, 0, half. So if you put minus lambda here and put minus lambda here and do your matrix, you are going to have that this is 1 minus lambda. In fact, put this like this. Put this straight so that they know that I want to get the determinant. So determinant is left minus right. So this is the left. Minus right is minus 0, which is equal to 0. So this is gone. So I'm left with just this being equal to 0. And when the product of two things is 0, automatically one of them is 0. So we have that 1 minus lambda is equal to 0, or half minus lambda is equal to 0. So we're having here that lambda 1 is giving us 1, and then lambda 2 is giving us half. And if you look at it, you see that the both of them is positive. And if the both of them is positive, we're going to have that this is unstable. When the both of them are positive, tell them that it is what? Unstable. Because they say we should determine the stability or asymptotic stability. So we tell them that it is unstable for J, for the first one. So we'll go for the second one. So permit me to clean here because we are done with everything here now. So I can do the second one and the third one and the fourth one. Then we are done. So for the second one, we are having that when I have J of, I think when it is 0, the other side was 1, like this. Or was 2. Okay? So J of 0 and 2 gave us minus 1, 0, minus 3 over 2, minus 1 over 2. Right? Is that correct? Okay. So if you want to get our engine value, we're going to have that here is minus lambda and here is minus lambda again. Here is minus lambda again. So if we do our determinant this time, we're going to have minus 1 minus lambda, minus 1 minus lambda, okay? And then minus half minus lambda. And this time this is 0, is equal to 0. So when the product of two things is 0, automatically one of them is 0. So minus 1 minus lambda is equal to 0, or minus half minus lambda is equal to 0. So therefore, lambda is minus 1 and lambda 2, lambda 1 is minus 1 and lambda 2 is minus half. So when the both of them are negative, we say that it is what? It is asymptotically stable. When the both of them are negative, remember, when the both of them are positive, we say that it is not stable. So when the both of them are negative, we say that they are asymptotically stable. So let's check for the next one. So the next one is what? J of I think 0, 1. Let me check if my time is still. Okay, J of 0, 1. So J of 0, 1 gave us 1, 0, sorry, it was 1, 0. So 1, 0 gave us that time minus 1, 0, and minus 1 over 4. Okay, so if you look at this, you are going to put our minus lambda again, and then put our minus lambda again, and then do our cross multiply to have that minus 1 minus lambda into minus 1 over 4 minus lambda again, and this time this is 0, is equal to 0. When the product of two things is 0, automatically one of them is 0. So we're going to have that this is minus 1 minus lambda is equal to 0, or minus 1 over 4 minus lambda is equal to 0. So therefore, lambda 1 is giving me minus 1, or lambda 2 is giving me minus 1 over 4. So when the both of them are negative, we say that it is what? Asymptotically stable. Asymptotically stable. So we go for the last but not the least. The last one but not the least. So for the last one, we have J of half and half. J of half and half will give us, it gave us that time, I think, minus 1 over 3, minus 1 over 2 minus lambda. And then here give us 1 over 2. Here give us minus 3 over 8. And here give us minus 1 over 8 minus lambda. Please check your own and be very sure. Please check your own and be very, very sure, because I think that is it. So let us do the same thing again. We're going to have that this time this is giving us minus 1 over 2 minus lambda multiplied by minus 1 over 8 minus lambda. Okay, then minus this time this will give us 3 times 1 is 3 and 2 is 16. Okay, is equal to what? 0. So, and minus is plus. This minus is because of the cross multiply. So from here we open the bracket, because we cannot do anything here. We must open the bracket and find out the quadratic equation. So to open the bracket, I have that this time this will give you 1 over 16. This time this will give you plus lambda over 2. I'm done with this one. So this one minus this time this will give you plus lambda over 8. Minus this time this will give you plus lambda squared. Then minus 3 over 16 is equal to 0. So multiply everybody by 16 so that the denominator will be out. 16 times this is 1, plus 16 times this will give you 8 lambda. 16 times this will give you 2 lambda. 16 times this will give you 16 lambda squared. 16 times this will give you minus 3 is equal to 0. So I'm having 16 lambda squared, and then this and this will give you plus 10 lambda, then minus 2 is equal to 0. So this is a quadratic equation that we are going to solve using our normal quadratic formula. Okay, so we're going to solve using our normal quadratic formula. So check if your own is corresponding with mine. Okay, so how did I get the 3? Okay, sorry. Okay, if you look at this, see that 2 can divide everywhere. If 2 divide everywhere, I'm going to have that this is 8h squared plus 5 lambda minus 1 equal to 0. So because 2 can divide everywhere, but solving with this will give you the same answer. But if not, you can still solve with this. And then let us now solve using our quadratic formula. So solving this using our quadratic formula, we are going to have that that our lambda is equal to this minus b plus or minus square root of b squared minus 4ac everything over 2a. So from here, our a is equal to 8. Our a is equal to 8, our b is 5, and our c is minus 1. So our b is 5, and our c is minus 1. So if you have that lambda is equal to minus 5 plus or minus the square root of 5 squared minus 4 into 8 into 5, then everything over 2 into 1. Okay? Now, the way I'm looking at this, it seems this is going to give us, what is it called? It's going to give us, okay, minus, what am I right? BAC, this is minus 1. So if you have this, you're going to have b squared minus 4ac. Yes. So this is minus 5 plus or minus the square root of 25. Minus minus is plus. 4 times 8 is 48. No, 4 times 8 is 32. So 32 all over 2. So if you do that, you're going to add the two of them to give you 57. So I'm having minus b plus or minus the square root of 57 all over 2. So separate it to have that the first lambda will give you minus 5 plus the square root of 57 over 2, or minus 5 minus the square root of 57 over 2. So I think you will see that the square root of this is going to give us a number that is higher than this. So you see that the first one is negative, while the second one is positive. So if one of them is negative or positive, we say that it is what? A saddle point. It is a saddle point. That is if the sign are not the same. See that everything here, minus minus, is going to be negative. So work this thing. In fact, if you work this, you are going to get approximately 0.16 for lambda 1. But for lambda 2, if you do this, you're going to get approximately minus 0.78 minus 0.78. So you tell them that since one of them is positive and the other one is negative, that it is what? A saddle point. So thank you very much for watching. Please don't forget to like this video, share to your friends, and then subscribe. May the peace of the Lord be with you. Bye-bye.